calculator. So when we've had questions where your answer was like 6 times 5 times 4 times 3 times 2 times 1, you could actually have used 6 factorial. The little factorial symbol means that it multiplies every number from that number going down by 1 until you get to 1. So if I did 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, I could just go 8 factorial. If I went 8 times 7 times 6 times 5 and stopped there, I couldn't, right? I have to go all the way to 1. So where is that button in your calculator? You're going to go 6. So you're going to go 6 and then math button. Over left once or right 4 times, but I would go left once because it's easier. And pick number 4. Then enter. So that was 6, math, left arrow once, number 4. So 6 factorial is 720. Do 9 factorial in your calculator. And 9 factorial is just 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 and equals that. Okay? So it's just showing that symbol that you can use if you're counting from that number all the way down to 1, going down by 1. Okay, we're going to look at permutations at the bottom. An internet site access consists of 3 digits. Knowing the 3 digits is not enough to access the site. The digits have to be entered in the correct order. The order of the arrangement of the digits is important. So remember I told you it's a permutation if order matters, right? So if you have to put it in a specific way, it's a permutation. If you don't have to put it in a specific way, it would be a combination. So combination locks should actually be called permutation locks because you have to put them in a specific 3-order manner, okay? John cannot remember the access code except that it contains the digits 3, 5, and 7. He knows the digits, so like just like if you walked up to someone's lock and they gave you 3 numbers and they didn't tell you what order, right? You just had your 3 numbers. List all the arrangements of these 3 digits that John could use to determine the access code. So he could do 357. He could try that. He could try 375. He could try 735. He could try 753. He could try 357. He could try 375. That's a 5. Oh, crud. He could try 57. Start with a 5. 573 or 537. So there would be 6 options that you'd have to try until you possibly, the worst case scenario, had to try all 6 to get in, right? So what's the way we could prove that? How many options does he have for the first one? 3, 5, 7. So 3. Then one of them has to stay there, right? So let's say we keep the 7. Then 3, 5. So 2. One of them has to stay there. So let's pretend we keep the 3. We'd have 5. So it's 6. There are 6 possible arrangements to consider, and only one of them will access the site. This type of arrangement, where the order is important, is called a permutation. If you ever read the word arrangement in a question, it's a permutation. The moment you're arranging something, you're putting it in a specific order. The moment you're putting it in a specific order, it's a permutation. So the word arrangement, if they asked you, if they gave you like 4 options on your diploma, and they said put 1 if it's a permutation or 2 if it's a combination, and they give you like 4 different examples, The moment the example has the word arrangement in it or arrange, it's a permutation. Okay? Next page. So, list all the arrangements of the word cat. So you could rearrange it. Or we could say, hey, we have C-A-T as my options. So I have 3. Then say I leave the T here, then I'd have C and A. So 2. Say I leave the A here, then I have C, which is 1. So I have 6 options. There is a way you can do this with your calculator as well. You know it's a permutation. The moment it's a word, it's a permutation. If anyone has phones out, which is a whole bunch of you, put them away. So you know that it's a permutation because it is a word. Order matters in words, right? Or else my name Crystal spelled differently would still mean Crystal. It doesn't. Words are always permutations. Always. Okay? So another way you can do this is you can use the permutation button. Now, it only works if you can't have repeats. Okay? If you could repeat these and it was 3, 3, 3, you wouldn't be able to use the permutation button. It only works if you go down by 1. Okay? So where is that button? You're going to do, I have 3 objects. So 3 letters. And I'm going to pick 3. And I use P because it's a permutation. Now where is that in your calculator? Well, you're going to go 3. You're going to go to that same spot as you did to find the factorial symbol. So math, left. And you're going to pick 2 for permutation. And then you're going to pick 3 again. And it's 6. The key thing is yeah. You could. Yeah, for this one it is because it goes down to 1. What happens though when I had like the word, what was one of the words we've used recently? Kelowna. Three factorial? What do you mean? What? So say we used Kelowna, but we were making 4-letter words instead. Okay? So we have 4 blanks. We have 7 letters for Kelowna, right? So we'd have 7, 6, 5, 4. In this case, you couldn't use 7 factorial because you weren't using the whole word, but you could use 7 letters. It's a permutation because it's a word, and I pick how many? 4. That would work, and those would get you the same answers. But if I was just rearranging Kelowna and it was 7 to 1, then you could use 7 factorial, you could use 7p7, or you could go 7 times 6 times 5 times 4 times 3 times 2 times 1. All will get you the same answer. Okay? All right. So I'm going to change these. Example 5 says determine the number of permutations in the letter of each word. Letters of each word. So we're going to do the letters of each word first. Okay? But then I'm going to make it a little bit harder. So Regina, it would be 7p7, or I could go 7 factorial, correct? Which is 5040, I think. Regina, Regina's how many letters? 6. 6p6, or 6 factorial, which is 720. Kelowna would be 7p7, or 7 factorial, or 5040, I think. Okay, now do rearranging Regina, but must start with a vowel. Rearranging Kelowna, and it must start and end with a vowel. Turns out Regina has how many vowels? Half of them are vowels, right? So 1, 2, 3, 4, 5, 6. The moment that it has a restriction, you can't use the P anymore, like just solely by itself, okay? So it has to start with a vowel. So my options are E, I, or A. So I have 3 options. Pretend I keep the A here. How many letters do I have left now? 5, 4, 3, 2, 1. So could I technically say 3 times 5 factorial? Yeah. And that is 360. Then we have Kelowna, which is 7 letters. It has 3 vowels. It has to start and end with a vowel scale. So how many letters do I have? How many vowels do I have? Okay, what are my options? So I have 3 for here, then what do I have to do? Okay, how many options do I have? So let's keep an E. Okay, E-O. So 2. How many do I have left for here? 5. Okay, question. How do I have 5 left here and not 4? Well, I used up the vowels, so I have 4 left. I still have a vowel left. So some people think that just because these have to be vowels, that I can't have vowels from the middle. That doesn't mean that. I used 1 vowel here. I used 1 vowel here. Let's pretend I used the O. I still have the E left for here and all the consonants. So it's 5 times 4 times 3 times 2 times 1. So I can write this as 3 times 2, which is 6. So 3 times 2, which is 6, times 5 factorial, right? What? No. It won't be. 720. There is this formula if I'm looking for NPR. So, say I use the word coral. And I want to know how many 3-letter words I can pick from coral. 3-letter words. So, I can go 5 times 4 times 3, or what did I say I could do? 5p3, right? There is a formula for NPR. This number here, can it be smaller than this number? Can I have 3 and pick 5? Does that make sense? 3 things and I pick 5? No. This number here, this N, NPR, this N has to be at least the same size as this. I can have 5 pick 5, or N has to be greater. So it either has to be the same size as R, or it has to be greater. So N has to be greater than or equal to R, always. Now, if I wanted to fill into the formula, this is the formula, NPR. So I have NP3, let's say. So I'm going to have N factorial over N minus 3 factorial. But what was my N? It was 5. So I could have actually went 5p3. So I'm going to have 5 factorial over 5 minus 3 factorial, because N minus R are all factorial. So this is 5 factorial divided by, what's 5 minus 3? 2 factorial. When you put that into your calculator, you're going to get 60. And what's 5 times 4 times 3? 60. And what's 5p3? 60. Yeah. Because this, you can use this formula if you want, because they can give you the answer like this. They can give you the answer as 5p3 instead. But this formula just shows you what your calculator is doing for you. Every single time your calculator is calculating NPR, it's doing this. It has an algorithm inside of it that does that. Okay, example 6. And then you're going to have some homework. In a region, vehicle license plates consist of 2 different letters followed by 4 different digits. If the letters I, O, Y, and Z are not used, how many letters do we have left? 22, because there's 26, so 22 left. Determine how many license plates are possible. Does it say that I can't repeat? So what do I assume then? That I can. The only time it won't say that you can't repeat and you can't repeat is if it's a word. It will never say you can't repeat. But you have the word coral. You have a C, you have an O, you have an R, you have an A, you have an L. You can't repeat because there isn't a repeated letter, okay? So don't mess those ones up. Okay, so we have 2 different letters followed by, actually it says different here. 4 different digits. What does different letters mean? You can't repeat. If it says 2 different letters, you can't repeat. That's another way it can say it, okay? So I have 22 letters for here. Then how many do I have for here? 21. Then here I have 4 different digits. What are my digit options? 0 to 9. So 10. But then I keep one there. So 9, 8, 7. Now, instead of going 22 times 21 times 10 times 9 times 8 times 7, which you absolutely can do, they could also have the option for you as I have 22 letters. I pick 2. Remember, if they can't repeat in order to use this, right? Times 10 numbers, and I pick how many? 4. And it'll get you the same answer. So this, they could have written as 22P2 times 10P4 as your multiple choice answer on the diploma. Now, what's stopping you from going 22P2 times 10P4, getting an answer, taking your answer and getting an answer, matching them? What's stopping you from doing that? Nothing. However, it could be a numeric response where they go 22Px times 10Py. What's x times y? Or they could say APB times CPD, where APB represents the different letters and CPD represents the different digits. What's A, B, C, D? Or A plus B plus C plus D. So you still do have to know how to do it because they can ask it that way instead. Okay? Your homework starts on question 7. So I want you to do 7. You're going to circle only the ones I tell you to circle. So 7. I just want you to answer 8. You don't have to do it in all 3 methods. I just want you to answer 8. 10. So 7, 8, 10. 12, 14. 7, 8, 10, 12, and 14.